Hello everyone, my name is Vanshi Sethi and today I will be presenting my second project for the course DA 378, that is Nutrition Coach, which is a multimodal Indian food nutrition system. So our agenda for today will be, firstly I'll define the problem context, like why this project or this thing was actually needed. We'll try to get an overview of it. Then I'll tell you my solution and I'll give it as an overview, like what is the architecture, what will be the tools used. Then I will share the data set and pre-processing techniques that we will be using in this project. After that, we'll talk about the methodology, the main YOLO V8, that is the state of the architecture, CNN model, along with nutrition DB and recommendation system that we have included. So what is the overall workflow? I'd like to tell that it will firstly detect the food components, different food items that are present in your thali, and then it will try to estimate the portion, and from that portions and the name of the dishes that are present, it will map it to a database of nutrition that is provided by the nutrition department of India, that is NIN. And then finally we have a recommendation system. This recommendation system is based on some kind of health issues. You can tell about a health issue that you are currently facing, and you can put a photograph of your thali. Then what it would do is it would try to run a recommendation system. It would tell you whether this food should be eaten or not, and not only that, it will also include some swapping techniques, what other food item you could include or how you can replace the food items that are not good for you as per your restrictions and health conditions. And then we'll talk about the conclusion, that how well our model actually worked. And in the end, I will also provide you a demo or of the code repository. We'll walk through it, and then I'll give you a live demonstration also, as I have a deployed model of it. So firstly, the problem. Why Indian food set is hard, or why this AI detection model is difficult to make. The main thing is that there are rising diseases in India. And apart from that, there are many teenagers who live outside their homes or do not have much time to discuss what to eat or what not. So they just need a simple companion that could help in all that. Along with that, many of the elder people are living alone, don't know much about nutrition, or even some people who are health enthusiasts or fitness enthusiasts, they can use this kind of system. So that's why we are trying to develop it, in order to help the youth and the elders, to help people in a make things more feasible, easy for them. And then the app gap was, there is an already existing app which is MyFitnessPal. I had used it. What was the problem there is that you have to manually select the food items, and along with that, for example, I'd say bhindi masala. In case of bhindi masala, they have written like bhindi masala of 1 cup or 2 cup. Like the quantities are totally, random. So we don't know what actually to choose. So this was really difficult to manually put all the things in this data. So that was the thing I felt was a loophole that we tried to manage. And also Indian food set was not there much, because it was mainly influenced by the Western food. Then the Indian food challenge, we got to know data scarcity of Indian food and also composite thali. Sometimes the food is overlapping. We need to detect it very accurately. So these are the things we'll do. So our solution is the Nutrition Coach, which is a website for now. So what we are doing is we firstly put the image of a meal, then we use the YOLO V8 detection model that has already been fine-tuned by us. Then what we do is we do the portion estimate. So what is happening in case of portion estimate? We are using the bounding box criteria for now, that is based on some research paper I'll share, because otherwise you will be needing the depth sensors, which we do not have. Because you can think like a person is taking a picture of their photograph, they would not be having depth sensors in their mobile phones. So the better option is portion estimate, like how much quantity is actually present. It would be an estimate, or a person can put it manually as well if they know. Otherwise, estimation would be there. Then it would map this table to the nutrition one, and it will look up how to match these things, what macro and micronutrients are present in what quantities. Then it'll look at your dietary restrictions also. And based on that, it will give you personalized feedback, what to eat, what not, how much you are eating, what is good, what is your nutrition score, these kind of things we are getting from our model. Next is the tools and techniques used. So we have mainly used Python, IPYNB notebook. Then I have used Google Colab for this because I needed T4 GPU to run this deep learning model. And then YOLO V8, our main architecture, state of the architecture. We have used the nano variant for now because the data set was small. And then we used Pandas, NumPy, the basic data processing and manipulation, rapid fuzz, why it was used. I would give you an example. For example, you have, let's say, aloo fry, and it could also be written as potato fry. So that is why some certain names mean the same thing. That is why we use this fuzzy string method. Next is the data set. The main data set that we have used is the Kaggle Rasoi challenge. So this is a publicly available data set which was used for some kind of Rasoi challenge, was available on Kaggle. So what we did is it had two folders. First one was standalone recipe, means only standalone dishes were present, single individual dishes were present. For example, only rice was there or only curry was there. Then also for the composite thali, there were multiple dishes present in the same picture, but they had already drawn some bounding box, provided us with notations also in some other file which we mapped. Then total merged, I got these many files, and also the annotation format, I would say it's VGG, visual geometry group. This is VGGNet, like we have already studied, were developed in Oxford, I think in UK. So then it was with JSON format, JavaScript object notation, just like dictionaries we are used. This is a semi-structured way of writing the data. We are using it. It mainly has C, X, C, Y. This is the center or the point we have selected coordinate X and Y. Generally in YOLO V8, it is the left upper part, left upper or right upper, mostly upper side corner. But left upper is the most, in most of the cases, common. Then we have W and H. These are the width and the height of that bounding box. Then data pre-processing and augmentation. So we had cleaned the data first. We have removed the white spaces, standardized it, and also I've converted everything in lowercase only just for the easy manipulation. I kept everything in lowercase. Then I did the normalization, and also the class mapping was done to get the data along with names. Like you had image earlier in one file, and other one was having only the name. Like in plate one, you are given image, and along with plate one other, it's written like curry and rice along with the bounding boxes. So these are the things we needed. Then class mapping also. So what we did in class mapping, we built a unified vocabulary. What is that? We merged both these data sets together because I felt that keeping standalone for training and this composite set only for testing, the composite set was much bigger as compared to the single set of standalone. That's why I didn't want that thing to happen, like the test case becomes very large and the training set is very low. So that's why I combined this first, and then I splitted it in 80 and 60. Validation here means the same thing as testing. Then what I did is I fine tuned the model. My model was based on COCO, that is common objects present. For example, there's a car or there is a bus or this is a flower. So these kind of things the model has already been trained on. So I just fine tuned it on my data set, and I realized it was giving very much accurate results. Some food were not available in much quantities. There I faced a problem. But how I tackled is I tried to give weight to every component present in my data. Like, for example, if watermelon images are low, I just added more weightage to it. That was from, again, a research paper, that what based criteria they have used. But it was based on Western food item, but I just tried to use it on my Indian food. Then we have the nutrition database, portion estimation and recommendation engine. So nutrition database was the one having the list of the micro and macronutrient along with the components or portions they are present. Then we did the portion estimation by our bounding box criteria. And finally, we have the recommendation engine that helped us swap the things. So this recommendation engine for now is simple rule-based criteria, that what actually to swap, as I have already considered 20 most common diseases in India for now. So what conclusion we got? Accuracy of 74.3%. I still feel it could improve, but for now it was this much. And then 20 health conditions were there, I have included. So the main takeaway was that this was feasible. Now accuracy can improve if we have more data. Actually, Indian food set is still lacking. And the second thing is that 20 health condition I've considered that are the most common in India. I've not considered each and every disease. And also for the portion estimation, it remains an open challenge because I still feel that a single food we can take its image from different angles along with the depth sensors. So that was the thing I feel we should tackle. And for this, I have included another part of this project that I will be able to do later as the deadline is there. Because what I felt is I could use transfer learning. I would take the image of rice from different angles. I would note down its quantity by myself and then add that notation. I will train this data and later on use the transfer learned on this model also. Then that way I feel it would improve a lot. So thank you so much. That was all for today. Now I'll walk you through our coding part. So what we did is we firstly imported all the important modules that we needed for this project. After that, I had tried to import everything from Drive. I had connected my collab with Drive and I imported all the data sets from there. Then I had also imported Shootil, which will later help us on saving our model so that every time we are trying to test on some new data, we do not have to train it again and again. We will have a saved model of the training that we had already done. So I firstly tried creating a list. That is, I looked at all the annotations that are present, the name of all the food component. If they are same, then we chose only one. This way I created a list of all the food component that were present. A total of 82 classes were present. Then what I did is I had imported the YOLO 8 because you cannot directly provide the annotated images to this YOLO model. It needs the data in its own format, that is the YOLO uh, structure. So what we did is we added it to that model and we converted and saved the annotations. We finally got some real boxes, fallbacks missing. And what we did is we then converted our thali to these YOLO labels, which we had already used using the bounding box criteria. Then after that, all the zip files, they were included, they were unzipped. And finally, we felt like we needed more images. So we used iCrawler. That is just it gathers the images or scrape the images from the web. You will provide the name of, or you can say certain keywords, and it will look for those images. Then it will save it to this path. Okay. You can see here it is skipping everything. This is because I had run this model twice or thrice. It had already saved more than 200 images. Okay, so that's why it is showing skipping, but I had actually included a lot many images. Uh, the one that are present in my data set were really low. After that, what I did is I auto annotated all these new images that I had gathered. Then we removed some images we do not need or we cleaned it. Then finally, using these annotations, we had added weights to it to compute. You can see here, breads were only 16, so the weight is very high. But cabbage was 76, that why the weight is low. So this is how we had provided weightage so that no food, dish is left out. Then what we did is we oversampled the low count images that were present for those classes. Finally, we built our YOLO data set. Then we decided how much to train and how much to validate. Okay, we divided it into groups that we needed. So what we got is we had this many standalone images in the training part. This one is validation. Then training and test, that is the same as validation. And extra images were this many, 8,229. Then again, after this, I verified the counts before starting. Then I created a YML list. You can see here, it has 82 classes again, you can see. Then finally, we run our model that was already trained on Coco. Now it will be fine tuned. So how it is fine tuning? You can see here the number of epochs is 45 and the image size is 320 cross 320. That size that we are taking in one iteration, it is equal to 32. Okay. And we are using the nano version. You can see here it ran for 45 epoch and here the accuracy final was 0. Means accuracy percentage is 74.3%. Okay. Individual for all is also given. And similarly, what I did is I saved this model to Shootle. And I also wanted to show you that I tried checking on some standalone images, like this is porridge, aloo sabzi, khichdi. Then you can see the full images also, like this is curry, bhindi masala, chapati, white rice, curd, and pasta. Similarly, I checked for other two also. You can see how well it detected. It has been written below it also. And in the end, I had also done the training, oh sorry, testing part. I'll show you the testing part. All these codes, let me tell you once, are for, you can see here, it is for bounding box, I feel. Yes, portion estimate. We are trying to estimate the portion. This was done using a research paper thing. And this is the bounding box criteria or estimate grams. You can see here dal is 170, another dal is 42, then chapati 15 gram, then gulab jamun is 15 gram. And again, we have this database that is YOLO to DB override. Uh, so a nutrition lookup model was ready. This was a fuzzy model because sometimes the names are a bit different but mean the same dish. And also we use this nutrition pipeline. We built the whole pipeline, included everything. We firstly gathered the image, we use that trained model. After that, on the trained model, we are trying to, include these dishes for testing. We'll get the estimate or portions, we'll map it with the nutrition, and finally get an estimate or the score, how well is your food, and a recommendation system based on it. So yes, you can see here, this is what I did in the end after building the pipeline. You can select a condition. After selecting the condition, you can click on this analyze the plate after adding the photograph. You can see here egg bhurji, chutney, and you have selected heart disease. Yes. So what does it say? Chutney you should not eat because you are a heart disease patient. And it also tells you how much nutrients are present, what is the estimated quantity. So this was the whole model. Now I'll show you a demo of it also. Here you can select on analyze your meal. You'll choose a photograph. Um, let's say we use the same one. I have it for now. Um, is that this one? Analyze the nutrition.